Good morning. Today we are starting AP Chemistry student, that is Singapore American School, you know, for the Singapore American School students. Okay, based on the chemistry are Jamhal, seventh edition. All diagrams from chemistry for Jamjal, seventh edition. So, student, what the chapter are you going to study? That is Unit 8, liquid solid solution. So, dear student, when you talk about the liquid solid solution, what comes in our mind? So, that is solids are very hard and liquids are comparatively volatile. And solid, when you talk about the student, solid, when you talk about, they are not compressible, but liquid can be up to certain extent can be compressible. So, here let us try to understand. We have already said that chemistry is the study of matter. Furthermore, we know that matter exists in three states here on the earth. So that is the gases are there. You can see the molecules have the random movement, and then here you can see the liquid molecule. What are there? Okay, they are not that much of arranged. Here is solid or completely arranged. Here you see. So systematic representation of three states of matter. The non-metallic atoms share electron. We have seen that they form the particles that we call molecules. Okay, non-metallic atoms like you can consider to be the N2, or you can also consider to be O2, Cl2. Shared electron, we have seen that they form the particles that we call molecules. So suppose nitrogen is there, they will share the electron. Oxygen will share the electron. They will share the electron and form the molecule. Okay, when we examine type of bond in the setting, in this setting we see that there are intermolecular bond that exist within the molecule to hold the molecules together. Okay, so it is, you now understood this is atomic bond. Now what the bond will be there between the two molecule of nitrogen, and what molecule will be there, that is two molecule of oxygen that we are talking about, that is known as intermolecular force of attraction, student, that are known as intermolecular force bond. Okay, then there are also intermolecular bond that exist between molecule. Okay, so intermolecular bond are significantly stronger than intermolecular bond. They are saying intermolecular bond significantly stronger than the inter uh, intramolecular bond. They are talking significantly stronger than intermolecular bond. Okay, that's keep in mind, intramolecular bond found in the same molecule here between the different molecules. So intra is stronger. It is the intermolecular bond that are broken and formed when matter change state or change phase. So always remember that, remember when a substance change phase, that is solid to liquid or liquid to gas, etc., the particle of the substance remains unchanged. Only intermolecular bonds are involved. Okay. This is why change of state, that is phase, are physical, not the chemical process. No new substance are being processed. For example, when ice melt, the heat involved is breaking hydrogen bond between the water molecule, not OH bond within the water molecule. Consider the energy required to both. Energy required to vaporize 1 mole of water is 740.7 kilojoule, and energy required to break OH bond is in 1 mole of water is 934 kilojoule. That is 23 times more energy required to break intermolecular bond compared to intermolecular bonds. Okay, so 23 times more energy required to break intramolecular bond compared to intermolecular bond. And remember that when the intermolecular bonding was hydrogen bonding to the stronger type of intermolecular bonding, the figure of intermolecular bond, that is 40.7 kilojoule, would be even less than less with the just dipole bonding, and even less again if only a London dispersion forces are there, LDF. Okay, dipole forces bonding. Okay, we are going for dipole dipole. We have already seen we have already seen that there's some molecule that contain asymmetrical bonding due to a differential electronegativity exist as a dipole. Differential electronegativity exists as dipole. In other words, one end of the molecule is different to other end in terms of charge. If this is the case, it is not surprising then if you bring such a molecule into close proximity and they are moving slowly enough that the positive end of the molecule will attract the negative end of the another molecule. So minus plus and minus plus. So how the when they are combining, they are forming, you see, three-dimensional network they are going to form. The electrostatic interaction of two polar molecule, the interaction of mini dipole condensed state. So molecule of this type dipoles are called a polar molecule. The stronger type of dipole bonding will exist in the primary when the polarity of bond within a molecule are at their greatest. Consider the stronger the polarity of the bond within a molecule, the molecule partial plus and partial minus, that is delta plus and delta minus. The end of the molecule will therefore, the stronger the attraction between the molecule will be. This is all based then the level of electronegativity of the non-molecule. The three elements with the highest greatest electronegativity F1, fluorine, oxygen, neon, that is fluorine, oxygen, neon. So with this in mind, this is the basis of the strongest type of intermolecular bonding, a type of bonding known as hydrogen bonding. There are two criteria that must be satisfied to classify the example of intermolecular bonding, hydrogen bonding. What are? That is, the positive pole must be hydrogen and the negative pole can only be F1, fluorine, oxygen and nitrogen. Possibly the best example of hydrogen bonding is between the water molecule. So this is the oxygen is there. Here is plus negative. So how this is going to